So all this checking you did about is this a binomial distribution? Fantastic. That's right. That's what we got to do because that's what helps us make sure that we're doing the right math, right? If it's not a binomial distribution, it's just not going to work for us. And for part here, let me come back. I got a bigger version of the rest of your work. What I do with your work. Here it is. Okay, and then for part A there, where you did five, if they had five people, what's probably all five will show up. That's the exact same setup, and you did that right. I never actually saw where you actually. Oh, right there, you did. There's the 0.58, but so you didn't have to add those because this was exactly five. So this wasn't five or more. Actually, that's all there is five, right? So all we want is just probably all five will show up. We don't care about the rest. They didn't say at least five, okay, or no more than five. I mean, it almost looks like that's what you're doing. Is you're doing like no more than five, and we want exactly five equals. Okay, so what's kind of cool about the math here is five minus five is zero. Zero factorial is one, and then so five factorial divided by five factorial is also one, and then 0.5 minus 5, remember, it's x. Well, you know what you're doing here. X minus n or n minus x, that's 0, and anything to the 0 power is 1. So all this math calculation really just boils down to the 0.8 to the fifth, which is that, and I see you had that there now. Okay. Um, to answer part B, and I didn't see where you addressed that, but let's talk about that here. So they said they've got 7 individuals. What's the probability that at least 5 will show up? So we're looking for the probability of 5 and the probability of 6 and the probability of 7. We could probably use that binomial table. I just grabbed my calculator and found the probability that there are exactly 5 people if there's 7 people we're choosing from, and 6 people if I have 7, and 7 people all show up, and the probability is the same. Found those probabilities and found the sum of those 3 probabilities. So that's part B. And then C, with the guessing and checking, I mean, I think that's where you're going with this. And you did this check to see, so we can't use means and standard deviations because this isn't a symmetric distribution, right? So we need another way to do it. So you wait a minute here, and I'm gonna make sure I'm gonna pull up this GigaCalc calculator, and we'll show you how to do that with there. Maybe you played with it, but really it's okay. You don't have to do all the formula work to make me happy. So in Canvas, in modules, I have this online statistical tools page. And then for binomial distributions, I've got this GigaCalc one that I tweaked it out. If you watched an earlier video, I use that stat check, which works great, but it doesn't always work lately for some reason. So let's talk about how to use this calculator for what we've already done. So there's the probability of somebody showing up is 0.8. And if we start with 5 people, what's the probability that exactly 5 will show up? And we calculate it. And as soon as this loads, here we go. There's exactly 5, and that's what we want. What you found is the sum of 5, or actually, yeah, I don't know. I guess I didn't do your calculation to see if we got one, but that would make sense if there's 5 events with probability that no more than 5 will show up. So that's that. Okay, so how about for part B, where I said, you added up those 3 probabilities, and I got like a 0.8 something number of events. We want 7 people, 5 or more, right? And then if we look at that, 5 or more. See that? That's that. There we go. So that includes 5. Let's see if I did it right. Let's see if I agree with what this calculator is telling me. Yeah, 0.852. And what's the calculator telling me? 0.852 rounds, right? Okay, so see how that works and how you use this calculator to decide what probability you're looking for, and then it does it for you. It's fantastic. Okay, now there's the other cool thing about this calculator that StatTrak doesn't do. You remember how, let's see, let's come back and look at the problem here. How many employees should you schedule in order to be 99% confident that at least 5 come to? So what we're looking for is here. Let me write. We're looking for what's the probability? What's the probability of uh, 5 or more? Okay, so we want to come up with how many. So what they're telling us, they aren't telling us n. So we don't know n. We know the probability is 0.8, and we're looking for 5 or more. Okay, so you see how what's different up here, they told us n. There's an n, here's an n. Here they aren't telling us n. And we want the probability to be 0.9900 or more than that. We'll probably never get exactly 0.99. But so what we do is we're going to come back to this calculator. We're going to go trials required because that's what we're looking for. And we want desired probability. We want 0.99. I honestly haven't used this calculator for this, but it should work for us. Okay, 10 trials are needed. See that? Isn't that? That's so cool. Before this, we had to do guessing and checking. So let's see. So let's go back and do some guessing and checking. Um, Number of events, number of trials. So I'm looking for trials. Let's calculate it. We know it's 10. See, that's not high enough. 5 or more, that's what we want it to be 0.9. So then we'd have to guess and check 6. Well, what is if it's 6? Uh, and sorry, nope, sorry, I did that wrong. 5 here. We have to make this 8. And close, getting better. And then 9 trials. And again, that's close, but not quite. So we probably have to go to 10. And let's see what that probability is. Yeah, 0.933. Okay, so the cool feature about this calculator, trials required, okay? We're going to do a similar thing with normal distributions in chapter 7. Much easier to do with normal distributions. Okay, so hopefully that helps you with this and use this binomial, use this calculator. You can use other calculators, spreadsheets do it. It's just this is like a this is like a Swiss Army knife. It does a lot. We don't have to think too hard about it. But interpreting it is the big thing. Okay, I'll stop this video and get it uploaded.